Hi again, everyone. I'm back with more of 5.4 solve trigonometric equations. And my third example here gets just a slightly harder. Sine theta equals cos 2 theta for theta between 0 and 2 pi. So we should notice, sorry, wrong one, want to change the color. We should notice right away this 2 theta jumping out at us. We have a double angle for the first time when we're solving trig equations. This should remind us of something, a double angle formula. So we can go ahead and replace the cos 2 theta with an identity double angle formula. You can take out your IB formula booklet or your textbook and look up your options for cos 2 theta. There are 3 of them. We'll want to choose the one that has sine in it because we have sine on the left hand side of the equation, and so that will make it easier for us to isolate the trig function. If we chose the one with cos in it, then we would have a hard time isolating either sine or cos. Likewise with the cos squared theta minus sine squared theta, that's not going to work as well either. So we're going to replace the right hand side with this double angle formula, 1 minus 2 sine squared theta. And then we need to try to isolate sine theta. So let's take everything over to the left hand side. 2 sine squared theta plus sine theta minus 1 equals 0. So I've taken everything over to the left hand side with the hope that I can isolate sine theta. But I have sine squared theta, and then I have sine theta, and then I have a constant term. Doesn't really lend itself to isolating it so easily. However, I should notice the pattern. The squared, the no squared or degree 1 term, and then the constant term. So this should look suspiciously familiar. Let me take this away, that doesn't look right. And it should remind you of a quadratic equation, right? Because I've got squared and then not squared and then constant. Sorry, it's kind of hard to write with these stylus things. Okay, so once you recognize that it's a quadratic equation, then the first thing that should pop into your mind, just think about it for a second. Solving a quadratic equation, how can I do that? I have 2 choices, right? I can either factor it, or if it's not factorable, I can use the quadratic formula. But this looks like it might be factorable. To make sure, let's, first of all, go back to my purple color, and let's do a substitution. We did this before with trig identities. Let's let A equal sine theta, because what that will do is it will make it look more like a quadratic equation and less like a trigonometric equation, which is going to make it easier to factor. So it is indeed a trinomial that we can factor. Let's just quickly apply our Australian method here. So we want a product of -2, a sum of 1. 2 factors are going to be 2 and 1. The signs should be +2 and -1 to get a sum of 1 in the middle. Take our A value, put it over the first factor, reduce it to lowest terms. Take our A value, put it over the second factor, it's already lowest terms. I'm just going quickly here with the Australian method because we've done it before, and I don't want this video to last forever. So now this becomes 2A minus 1 times A plus 1 equals 0. And I'm going to isolate A in each bracket to solve for A. So if this was just a quadratic equation that I was solving, then I'd be done. However, we need to not forget that our A is actually sine theta. So we need to put that sine theta back in for A now. So what we actually have is sine theta equals a half, sine theta equals -1. Okay, I'm going to go to the next page. So on the previous page, we stopped at sine theta, whoopsie, sorry, sine theta equals, was it -1? Or it was 1/2 and -1. So 1/2 and sine theta equals -1. Okay, and now we need to solve these. So let's start with the 1/2. I think we did this already for a previous question. Which quadrants are we in? I'm just going to go through it quickly since we've already done it. It would be 1 and 2 since it's positive. So I need my related acute angle, alpha, which is going to be the sine inverse of 1/2. According to special triangles, that would be pi over 6. And therefore theta would be pi over 6 in the first quadrant and pi over 6 in the second quadrant. Answers to theta would be pi over 6 and pi minus pi over 6 in the second quadrant, which is 5 pi over 6. Okay, so these are my answers, final answers from the first trig equation, which is sine theta equals a half. But I also have this guy over here. Let me just go back to, oh, I don't even know what color I was using. Never mind, I'll just stick with this red for now. I need to know for what angles is the sine -1. So remember that we can't get that from a special triangle. We need to use our unit circle. And the first coordinate of each point is going to be the sine of the angle theta. Cos of the angle theta. Second coordinate is the sine of the same angle. So we're looking for the second coordinate to be -1. That would be down here at 3 pi over 2. Because the coordinates of that point would be 0, -1. And that means that theta in this case is equal to 3 pi over 2. So that's another solution, and we should just make sure that they agree with our domain that we were given, which is that theta has to be between 0 and 2 pi. So pi over 6, 5 pi over 6, 3 pi over 2, yes, they're all less than 2 pi, between 0 and 2 pi. So we're good. Let's move right into the next example and get rid of this. And the examples are going to get slightly, progressively more difficult as we go. Of course, because math never leaves well enough alone. It always has to keep getting harder and harder. Unfortunately, but that's life. Okay, and as I always say, it's good practice for real life. Math is the best practice for real life because it challenges you, and so does real life. As we know right now, we're being challenged by the COVID-19 virus, but hopefully staying home for a while and not coming to school is going to help us to flatten that exponential growth curve, and pretty soon it will look more like that, hopefully, and we can come back to class. Anyway, that's a sidebar. Let's get back to our trig equations. So again, we have our friend, the double angle here to deal with. We could go ahead and replace that with an identity. Let's say the 2 cos squared x minus 1, or even the 1 minus 2 sine squared x. That would be fine, and you could go ahead and solve it that way on your own. I'm going to not replace it because there are situations where you can't replace with an identity, where you have a double angle or possibly even a triple or quadruple angle, like 3x or 4x. So I want to show you how to do that. So we're just going to do it straight from this equation. Okay, so what we're going to do is follow the same steps. First thing is to locate the quadrants that we're in. Since cos is positive, we're in quadrants 1 and 4, where cosine is positive. We still need to find our related acute angle, which is alpha, by doing the cosine inverse of 1/2, which from our special triangles would be pi over 3. Put that in our two quadrants. And then we go ahead and find the standard angles that go with each of those related acute angles. In the first quadrant, it's still going to be pi over 3. In the fourth quadrant, it's going to be 2 pi minus pi over 3, which is 6 pi over 3 minus pi over 3, which would be 5 pi over 3. The only difference is these two angles now are not equal to x, but equal to 2x. Now before we go ahead and divide these angles by 2 to find out what x equals, we need to keep going for a bit, because remember our domain up here, x between 0 and 2 pi, well, that was only applicable to x. We need to know what should the domain be for 2x. So we'll just change that up here by multiplying everything by 2. 0 stays 0, 2x, x becomes 2x, 2 pi becomes 4 pi. So what we really need to know is what is the domain for 2x, and that is 0 to 4 pi. So how does that affect us down here? What it does is it means that we need to keep going to find more answers. So we've got pi over 3 and we've got 5 pi over 3. What is the next coterminal angle to pi over 3? Well, if you remember the definition of coterminal angles, you would add 2 pi to pi over 3, which would, just do a little arithmetic, 6 pi over 3 plus pi over 3 would be 7 pi over 3. Is that less than 4 pi? Yes, because 7 over 3 is just over 2 pi. Okay, so that's still in our domain of 0 to 4 pi. What happens if we do coterminal to 5 pi over 3? 5 pi over 3 plus 2 pi would be 5 pi over 3 plus 6 pi over 3 is 11 pi over 3. Let me just get rid of this, okay? So it's not running into my 11 pi over 3. 11 pi over 3, is that less than 4 pi? Let's see, grab your calculator. 11 over 3 is 3.7 approximately, so it's just under 4 pi. Now, we would keep going with coterminal angles, keep finding coterminal angles until and unless we go over 4 pi. Well, if we did the next coterminal angle, so if we added, let's say, 2 pi to 7 pi over 3, because that's the next angle we haven't added it to yet, that would be over 4 pi, because that would be 7 pi over 3 plus 6 pi over 3, which is 13 pi over 3, which is greater than 4 pi. So we're not going to do that. So we're almost done here. Right now we have 2x equals pi over 3, 5 pi over 3, 7 pi over 3, and 11 pi over 3. Let me just fix these, they're kind of messy, sorry. Pi and 5 pi, okay? But we don't want to know what 2 pi is. We want to know what pi is. We don't want to know what 2x is, we want to know what x is, right? So we need to divide each of these angles by 2. So pi over 3 divided by 2 is going to be pi over 6, because we just multiply by a half. 5 pi over 3 becomes 5 pi over 6, 7 pi over 3 becomes 7 pi over 6, and 11 pi over 3 becomes 11 pi over 6. If you have trouble with dividing by 2, just write it out the long way and do it, okay? And just verify for yourself that these are actually the answers. Okay, so those would be our final answers to this wonderful equation that we started on the previous page, cos 2x equals 1/2. So the additional complication here was that we had to change the domain to match the argument of the cos that we were given. Remember, this is called the argument of the trig function. And we had to keep getting coterminal angles until we reached our upper limit on the domain. And then finally, we had to divide by the number in front of x to get our final answers for x.